Hey kids, Flexing Teacher Weber here. I hope you're having a good day. We have been studying factors. Factors are the numbers that multiply to a given number. And specifically, today we're going to look at prime numbers and composite numbers. Now, what a prime number is, prime numbers are numbers that only have two factors, one and itself. So an example of a prime number is 13, because its only factors are 1 times 13. Or 5, because its only factors are 1 times 5. Or 23, because its only factors are 1 times 23. Composite numbers are numbers that have more than two factors. So any number that has more than two factors is a composite number. So some examples are 12, because it has these as its factors: 1 times 12, 2 times 6, 3 times 4. 8 is composite because its factors are 1 times 8, 2 times 4. 18 is composite because its only factors are 1 times 18, 2 times 9, 3 times 6. So any number that has more than two factors is composite. So what we're going to do today is we're going to do something called the Sieve of Arastones. It sounds very complicated and mathematical, but what it's going to do is it's going to help us find all of the prime numbers, the numbers with only two factors, less than 100. So let's read the part that says background information. A prime number is a whole number that has exactly two factors, itself and 1. This means that 7 is a prime number and 4 is not. Since 1 only has one factor, 1 is not a prime number. More than 2,000 years ago, a Greek mathematician, Arastones, invented a system for finding prime numbers. This system is called the Sieve of Arastones. It's based on a number grid. So here's what we're going to do. And the directions on this paper are a little bit incorrect, so I need to correct them. So it says, use the grid system of numbers from 1 to 100 to locate those primes less than 100. First, cross out 1. So we'll cross out 1. Okay, now what it says is to cross out all the multiples of 2 using this symbol. Now, what it's not clear about, though, is we should cross out all the multiples of 2 except 2. The first multiple of 2 is 2, but we're not going to cross that one out. We're going to start with 4, then 6, 8, 10, and we're going to skip count by 2s, and we're going to cross out all the multiples of 2 up to 100. You're going to see a pattern here in a second. I believe I can just do this now. And that will cross out all the multiples of 2 up to 100. Okay, that was our first job. Second job, using this symbol, cross out all the multiples of 3, but I want to clarify this again. We don't want to cross out 3, which is the first multiple of 3. We want to leave the 3. So I'm going to change colors, and I'm going to start crossing out all the multiples of 3 except 3. So 3, then 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, 39, 42, 45, 48, 51, 54, 57, 60. There's sort of a neat little pattern going on there, isn't there? Okay, 63, 66, 69, 72, 75, 78, 81, 84, 87, 90, 93, 96, 99. There's this neat little diagonal pattern, isn't there? Where they all sort of go in diagonals. Now, the next instruction says, use this symbol to cross out all the multiples of 5, but I'm going to clarify that again. We don't want to cross out the 5 itself. So we'll start with 10, so we go 5, but the first one we'll cross out is 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100. Boom. All the multiples of 5 are crossed out except 5. Okay, the last thing we want to do is using this symbol, cross out all the multiples of 7. And I'll change maybe to a green color here. And but I'm not going to cross out the 7, right? So the first one I'll cross out would be 7, but then I'm not going to cross that out. I'll do 14, 21, 28, 35, 42, 49, 56, 63, 70, 77, 84, 77 and 7, 84, 91, and 98. Crossed out all the multiples of 7. There's an interesting diagonal pattern there as well. Okay, now the numbers that are remaining that have no crossing out are all the prime numbers less than 100. So let's list them out. The first number I see is 2, 3, 5, 7, 11, 13, 17, and 19. $23 and $29. $31 and $37. Got to make sure I don't miss one. 31, 37. 41, 47. Oh, and I missed 43. So 41, 43, 47. Okay, in this row I have 53 and 59. Okay, and the next row I have 61 and 67. Okay, in the next row I have 71, 73, 79. Running out of space here. In the next row, I have 83 and 89. And I hope I haven't missed one. 83, 89. And in the last row, I have 97. All of those numbers are the prime numbers less than 100. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Those are the 25 prime numbers less than 100. Those numbers have only 2 factors. The next thing we did today is we just talked about whether these numbers are prime or composite. So write the factors for each number and state whether they are prime or composite. So 15, we would have 1 times 15, 3 times 5, and since it has more than 2 factors, it is composite. Whereas 1 times 29 are the only factors for 29, so it is prime. And we did a couple more of those. 47. Its only factors are 1 times 47, so it is prime. Whereas 16's factors are 1 times 16, 2 times 8, and 4 times 4, so we just list the 4, so that makes 16 composite because it has more than 2 factors. So that's a little rundown of prime numbers and composite numbers and how we find the prime numbers. I hope that helps. That's all for now. Flexing Teacher Weber, out.